This is Mr. Anderson for Kellogg Community College, and we're going to be looking today at the final exam review, part 11. This is our 11th 14 pages here, so this is a good page here, a lot of tricky stuff here. We're going to perform the following operation, which is, it looks like we're just going to divide, but actually what we're going to do is we're going to conjugate, or we're going to complete the square in the denominator, because we can't have I in the denominator, and the reason why we can't have I in the denominator is because I is the square root of -1. We can't have square roots in the denominator, so what we're going to do is we're going to multiply our numerator and denominator by a very fancy 1, and that 1 is going to be the binomial of 1 plus 4i. 1 plus 4i. Now what I'm going to do is FOIL the numerator and FOIL the denominator and make two different parts of my fraction here. So let's take a look at this. 3 times 1 is 3. 3 times 4i, that is 12i, excuse me. 6i times 1 is 6i. And 6i times 4i is positive 24i squared. Now, I just want to focus on this numerator for a moment. 24i squared is the same thing as negative 24. Because since I is, by definition, the square root of -1, then I squared would be the square of -1, the square of the square root of -1, which would then be -1. So this would then be 3 minus 24, which is negative 21. And what's left over there is our 18i in our numerator. Okay, in the denominator, what we have here is we have 1 times 1, which is 1, 1 and 4i, which makes 4i. Negative 4 and 1 makes negative 4i. And then negative 4 and positive 4 is negative 16i squared. Negative 16i squared is the same thing as 17. These 4i's are opposites, so they simplify. And so what we have here is, I wrote 17 because I looked ahead in the work here. The negative 16i is going to be turned into positive 16. 1 and 16 is 17. So negative 21 plus 18i over 17. And that's the correct format. The format is a plus bi. You could split it up into two fractions like this, but it doesn't actually simplify anything any easier. So either of these is going to be the correct notation. Now this I is equal to square root of -1. We're totally going to use that in problem number 46 here. So this is going to be the square root of 49 times the square root of -1. So this is 7i. Now, if you only looked at the positive value of that, that's true, but some professors might want you to put plus or minus, depending on if you're supposed to consider not only the positive but negative roots of any square root there. Okay, so for this next problem here, we're going to take a look at trying to simplify this, and we're going to start off by seeing what we can do to extract some of these, because you'll notice that in this first radical here, I can rewrite these like fractions, like a to the 4/2, because since that's a square root, I can turn all of these into powers of inside an index here. So this would then be b to the 3/2, and this would be c to the 4/2. And I'm going to multiply that by a to the 1/3. This is the second radical right here. B to the 2/3, and then c to the 1/3. Okay, so now what I'm going to do is I'm going to put these together, and I'm probably going to change the a and the c. Notice that the a and the c are all like, you can change these numbers a little bit. So this is a to the 2nd power times a to the 1/3 power, and I'm just reordering these. And then I'm going to have b to the 3/2 power times b, or all these would be multiplied, sorry, didn't need to put the plus symbol there. B to the 3/2 and then b to the 2/3, and then that's a bigger multiplication sign, c to the 2nd power, and then c to the 1/3 power. Now what I'm going to do is add these two pieces together, because if they have the same base, you can just go 2 plus 1/3, and here I can go b to the 3/2 plus 2/3, and then c, and then that's going to be 2 plus 1/3 again. Now what I get is I get a over here. Now 2 plus 1/3. If I get common denominators, it'd be 7/3 here. There's 7/3. Now here, if I'm going 3/2 and 2/3, the common denominator there would be 6. So that would be 9/6 if I multiply top and bottom here by 3. And this would then be 4/6, again multiplying the top and bottom by 2 here. And so that would give me 13/6 for B. And then C would also be 7/3 just because A was. And for me to finish my answer is that I can turn these 7/3 into 14/6, so I can put these all under the same radical. So B to the 13/6 and C to the 14/6. So what I have here is now I have the inside out. I have the 6th root of A to the 14, B to the 13, and C to the 14. And again, you can look at this as taking things out, because 6 goes into 14 twice with 2 left over. So there's your A squared. 6 goes into 13 twice with 1 left over. And then C goes into 16, or the 6 goes into the 14 twice with 2 left over. It's not the only way to do the problem. It's just one of a couple different ways. It's the one that I've been teaching when I do that with my students, though. Okay, in problem chapter 8 here, I'm going to now use the quadratic formula if I can't factor. So I'm going to subtract the 6h from both sides. So I get h squared minus 6h plus 4 is equal to 0. So what this means is that since I can't find two numbers to multiply to make 4 and add to make -6, I'm going to have to use quadratic formula. So I'm going to use A is equal to 1, B is equal to -6, C is equal to 4. So my quadratic formula is going to look like 6 plus or minus the square root, -6 quantity squared minus 4 times 1 times 4, all over 2 times 1. Now if you did the work here, you're going to get down to 6 plus or minus the square root of 20, all divided by 2. And this is where I split my wheels up a little bit, because when I simplify this, it's going to be a little bit easier to see that that would be a 3. Now the square root of 20 can be broken down into the square root of 4 and square root of 5, or 2 square roots of 5. So if I have 3 plus or minus 2 square root of 5 over 2, the 2's simplify, so my answer becomes 3 plus or minus the square root of 5. And that would be my answer for the problem. 3 plus or minus the square roots of 5. And that would be fully simplified. Alright, let's take a look here. Oh, there we go. Move this down a little bit. Alright, 2 more problems to go. Okay, so another quadratic formula problem. Notice that I have to do a little bit of work to get this prepped here. So I've got x squared minus 4x plus 9 is equal to 0. There are no two numbers that multiply to make 9 and add to make -4. So off to use the quadratic formula again. And this one's going to have some imaginary answers, so let's check it out here. We are going to now load up the quadratic formula. 4 plus or minus the square root, -4 quantity squared, make sure you put your parentheses around that, minus 4 times 1 times 9, all divided by 2 times 1. Okay, and what that gives us is this gives us 4 plus or minus the square root of -20. Now, remember in the previous problem we had positive 20? Well, this breaks down to the square root of 4, the square root of 5, and the square root of -1. So that means I'm going to have 2 plus or minus 2 square root of 5i divided by 2. 4 divided by 2 is 2. Now these get divided out. So I have my answer of 2 plus or minus square root of 5i. And that's in the a plus bi format. Our last problem here is the quadratic equation. And one more thing you're supposed to do here is I want you to clear the denominator of fractions, because we're not going to leave our problem like this. We want this to look like a ABC quadratic equation, and we're starting with the answers that it hits the ground at -4/3 and 3. So we're going to set this up into the x minus p, x minus q equals 0 format. So that will be x plus 4/3 and x minus 3. And since this is x minus p, x minus q, it's opposite of their answers on the ground. Now we're going to FOIL this. Now to FOIL it out, what we will do is we will just do our first cable here, our x times x, our x times negative 3, our 4/3 times x, and our 4/3 times negative 3. And 4/3 times negative 3 is just negative 4. Okay, so what that's going to do here is, because 4/3 times 3, if you want to see it written out, it's actually negative 12/3, which is negative 4th. That's going to be equal to 0. Now, normally I would combine my middle two terms. I forgot my x. Normally I would combine these middle two terms, but instead I'm going to multiply everything by 3. And the reason why I want to multiply everything by 3 is because that will clear my denominator. The 4/3 will become a 4. So my first term is 3x squared. Geez, I forgot my x squared there. Minus 9x. I should make that a 9. Ooh, that's pretty ugly. 9x plus 4x minus 12 equals 0. Now I combine my middle two terms here. So my answer is 3x squared minus 5x minus 12 equals 0. And that gives me my quadratic equation that will give me these two answers to my problem. All right, well, hey, thank you for watching.